Hello everyone, welcome to our first recorded lecture in MATLAB, and this is really my first time recording, so please bear with me. And I recorded this lecture in order to support or to help you out in or to give you some insight on how to do the problem set. So I will be having one example today, and then all of what I'm going to do today, or everything that I'm going to do today, is purely related in MATLAB, so in the module that I gave you. So my lecture or this video will support the module, and the module will support this video. So without further ado, let's get started. Okay, so for today I'm just going to have a simple example, and that is the projectile motion. So that is one of my favorite topics in physics, and I really had I feel that you feel the same way as well. And if not, okay, I hope that you find this video very exciting. Okay, because what we're going to discuss first is will be, or what we concluded from what we're going to do here in the blackboard muna, would be we will be putting it out in MATLAB as well. Okay, so here, say for instance, I have an object here on an even surface, and is launched at a speed of v0 and is given by an angle alpha. Okay, of course this one has a horizontal component v0 v0x, which is equal to, of course, according to physics, v0 cosine alpha. Next, on the y component as well, we have here, it is given by v0y, which is equal to v0 sine alpha. Now our goal here for this computation, or determining the formula, is to determine the formula for x and y in all time. So meaning I want to know where exactly is that object at all points in time. So whether it is at 1 second, or at 0.07 seconds, or 0.035 seconds, I want to know the location of that ball on its x and y axis. So we have two equations in mind. So equation natin is yung x natin, meron tayong x of 0 plus v0 x, which is this, by the way, times t, plus 1/2 a of x, your acceleration in the x component, times t squared. Okay, and then since we assume that the object starts at 0, so this cancels out, and the acceleration in the x component, as we all know in physics, is also 0, so this term cancels out. So we are now left with x is equal to v0 x times t. That's all. Now we go with y. Y is just the same, but all x changes to y. So y of 0 plus v0 yt plus 1/2 acceleration in your y component multiplied by t squared, whereby we assume that your acceleration and your y component is equal to minus g. Okay, so simplifying further, we have y is equal to y of 0 plus v0 yt minus 1/2 gt squared. That's all. Now the next thing that we need to do is to really determine how are we going to when is it going to reach its maximum height, or rather when are we going to know when it will hit the ground, yung ating ball. So let's take first equation this one. Okay, and let's take first the maximum height now para mas madali nating malaman. Okay, we all know that if we take the first derivative of this becomes v at your y, that is equal to, this cancels, but this now becomes v0y minus gt. Okay, now since v0 is not 0, it started at a certain speed, so but at the maximum height the final velocity becomes 0, so this becomes 0 equals v0y minus gt at maximum height. So let's put this an h, so this is to indicate that it is the time to reach its maximum height. So transposing this, we get that the time it takes to reach the maximum height is equal to your v0y, which is v0 sine alpha divided by g. Now of course, the time that it takes to reach its maximum height is also the same time that it takes to reach the ground. So from there, we conclude that the time that it takes to hit the ground, t of g, is equal to twice t of h. So therefore, we have t is equal to 2 times v0 sine alpha divided by g. So ayan. So given these three equations, this one, and this one, yung v0x times t, and then yung y is equal to y0 plus v0 yt minus 1/2 gt squared, and then together with tg is equal to 2 v0 sine alpha divided by g, we can determine the x and y components. Okay, so lagay lang natin dito. So we have t at the ground is equal to 2 v0 sine alpha divided by g. That is our first equation. That is what we need to know before we can figure out the others. Next, we have x. X is equal to v0 cosine alpha multiplied by t, and finally our y is equal to y of 0, which is 0 by the way. Okay, so tanggalin na natin yan. 0 rin lang naman yan, so no worries. So v0y, so v0 sine alpha multiplied by t minus 1/2 gt squared. Okay, so these are yung pasunod-sunod ng ating solve. So we need to solve first t in order to get x and y. Okay, so what are the variables that we need to declare for this to happen? So we need, first of all, we need v of 0, we need alpha, and we need g. That's all there is. Okay, with this I can find time, and with time together with v0, alpha, and g, I can solve for x. At the same time I can solve for y. So these are the independent variables that I need, and then these are the things that we need to solve: t, x, and y. Okay, and of course yung time natin, kailangan natin siyang i-declare from 0 until the answer. So from 0 to t of g. So t as a function of 0 until t of g. Kasi ang goal nga natin is malaman yung position ng object from time that before it starts until it reaches the ground. So 0 to t of g. So what would be our strategy here? Okay, so strategy muna tayo. So what would be our strategy? Okay, so ang strategy natin is step number, so ang strategy natin, so we need to declare v0, we need to declare g, and we need to declare alpha. Okay, so it is always very nice to use this method first before going into MATLAB, para alam natin kung ano yung magiging workflow ng ating gawa. Next, solve for t of g. Solve for t of g by solve t of g, and then number 3, declare t. So we need to, yung answer kasi dun sa t of g is iisa lang ang value niya. I need to spread it out into multiple number of entries. So ang gagawin ko is I need to declare another variable which is t that has a formula of linspace, command linspace, from time 0 until dun sa answer niya sa t of g. Okay, so ang mangyayari is from 0 to t of g, whatever the answer is in t of g, gagawa niya ng 100 entries. Okay, mamaya makaiintindihan mo kung bakit. Okay, so number 4, we now solve for x. So using the formula that we just have dun sa nakaraan. Okay, maybe I could delete this. Okay, so galing dito, and then finally solve natin for y, and yung goal natin is to plot the trajectory. So ang gagawin natin dito is plot in x, y. So yun yung gagawin natin. Okay, so now we're here in MATLAB, and we need to have an example first. Okay, so if here in MATLAB, let's try to declare some variables first. Okay, so I want to have v0, alpha, and g, because yan yung mga constants na kailangan natin. So let's have an example. Say that there's an object moving at 10 meters per second with an angle of alpha, and we are firing it here on Earth, of course. So 9.8 meters per second squared. So determine the trajectory of this object given these initial parameters. Okay, so in MATLAB, punta na tayo dyan. declare na tayo ng variable. So v0 is equal to 10. Suppress that. So we need to suppress that, okay? Pwede rin naman sigurong v0, but I find it much easier to use this. Okay, so v0, and the gravity, which is 9.8, and then we have alpha, which is equal to 45 degrees. So enter, and as you can see, it gets declared here sa gilid under workspace. Okay, next, according to our open board, we need to strategize. So let us now following the strategy that we have initially, let us now try to solve for T of G. So okay na yan, nagawa na natin to. Declare na natin yung v0, g, and alpha. We need to solve for T of G. So T of G, so T underscore G is equal to, so referring to our blackboard, so we have 2v0 sine alpha divided by G. Okay. Okay, so let's start by opening a parenthesis. 2 times v of 0, because that is the variable that we have here, multiplied by 2v0, then sine of alpha all over G. Suppress that, and then you see that the answer displays here, so 1.76365. Now, so tapos na tayo dyan. Okay, so balik tayo dun sa strategy natin. We already solved for T of G. Now let's try to declare the linspace. So T is equal to linspace of 0, T of G. Okay, so going back here, T is equal to the linspace, the linear space from 0 to T of G. Pwede yan apparently. No? Hindi ko to isusuppress para makita nyo. As you can see, it creates 100 entries from 0 to your final answer. And that is now going to be used in solving for x and y. So not only it will solve for 17365, it will also solve for all of the entries within T. Okay, I hope I make sense. Okay, so cancel natin na to, and then let's solve for x. So yung x natin is equal to v0 cosine alpha times t. Okay, so here in MATLAB we have x is equal to v0 times the cosine of alpha, and then multiply the entire thing by t. Okay, multiply the entire thing by alpha, then you get the same answer. So kung yung t natin is 1 by 100, yung answer natin for x is 1 by 100 as well. Okay, so next let's do the same thing for y. So as you can see, y natin is v0 sine alpha times t minus 1/2 gt squared. So dito na tayo, y is equal to, ulit yan, v0 multiplied by, so let's try to open this up with, so maybe I could clear this up first para medyo malinis. So y is equal to v of 0 multiplied by the sine of alpha. So let's close everything here, multiplied by t minus 0.5, because 1 divided by 2 is 0.5, multiplied by the gravity, which is g, times t, which is element wise. Bakit natin i-element wise? Because pag t square lang alone, ang mangyayari is magkakaroon ng matrix operation na yung 1 by 100 i-multiply niya sa 1 by 100, which is impossible. No, diba? Dapat the same number of columns ng matrix A should be equal to the number of rows ng ating matrix B. So 1 by 100 multiplied by 1 by 100 is not possible. So ang gagawin natin is lalagyan natin ng dot to make it element wise, so that all entries inside the matrix will be squared instead of t times t. Iba rin yun. Okay, so let's suppress the thing, and as you can see, yung y din natin is naglabas ng 1 by 100 na results. Okay, so now we are now only left with number 6, which is yung plot the trajectory. So as said here, i-plot natin by x and y. Okay, so here in MATLAB, let's just simply type plot open parentheses x comma y. Okay, enter, and as you can see, this is the trajectory of the object. Okay, so as you can see, ito yung lumabas. Alright, that is the trajectory of the object now. So let's have some fun a little bit. Now let's make it some color, and then let's put some circles in it, para there's a resemblance that is the object in time lapse. Okay, so let's try that. Okay, so if you want to refer to the module, if you try to refer to your module and you refer to the table, so x comma y, and then you add another comma, and then a single quote. A single quote, I want it to be circle, so type O, and then maybe I could put some green on it. Okay, pwede yan. Let's put some green on it, and then close parentheses, and then it displays fix this, window capture. Okay, and as you can see, it displays a much better figure. And this is the object, and then at every point in time, as you can see, the reason why there are many circles here is because we set 1 by 100 entries dun sa lane space. Okay, so there will be 100 balls in here with respect to time. Okay, and that is pretty neat. So, but if we declared t in just a single value, like yung t underscore g, ang mangyayari is iisang object lang yan, and that would be at the time that it hits the ground. Okay, we don't want that. We want the entire trajectory from 0 until it hits the ground. Okay, so guys, I hope that you find this video very meaningful. Thank you very much, and I hope na may naintindihan kayo. If you do, and if you have questions, I'm always free. Okay, and if you like this video, leave a like on this video, and I hope that I really need some encouragement in posting more videos, and I hope that you find this video very meaningful, lalo na sa inyo, mga slow learners, na I'm not really humiliating you, but this is intended for you. Okay, and I cannot be really on time, kaya I planned on posting this video. So I hope that you like this video. Stay safe and have a good day.